Hi, this is Brett McDonald, instructor for Atmospheric Science 2000, Introduction to Meteorology. Today we're going to go through a little presentation to give you some help on drawing isobars on a weather map. This goes right in line with Module 01, so hopefully by going through this it can help you get started because you might feel a little uneasy doing this. So first thing to remember that you learned by reading Chapter 1 is that isobars are lines of constant pressure. Basically, when we look at the map, it's kind of like a connect the dots, but you need to interpolate a little bit. So here in Wyoming, we have a really good experience looking at topography maps. And on those maps are lines where those lines are contours of constant elevation. So most of you should be pretty familiar with what these contours are. Note that on most maps where we draw isobars, we're going to draw them at very specific values. Every 4 millibars centering right around 1,000. So if you see a map, you can start with the 1,000 millibar contour and start going 4 millibars either way in order to draw it out until you just don't have the data to support it. So let's start off by looking at some surface pressures over the eastern United States. This is a figure that is very similar to figure 1 that you'll find in Investigation 1A. So here there are a couple of isobars already drawn. There's a 1016 isobar across central Florida. There's a 1020 that goes kind of above northern Florida, but also then winds its way up the east coast. And then there's also, again, another 1016 isobar over in Texas. For me, what really helps is identifying the lowest and the highest pressures on the map. In this instance, we have a 998 at Chicago, and we have a 1023 over the Outer Banks of North Carolina. These are the low and the high pressures on this particular map. So what I typically do is I'll put a L over the low pressure area and the H over the high pressure area. So again, if you're trying to relate this to a topography map, think of your H, your high area, as kind of like your mountaintop, and your L as kind of your lowest elevation, down low. So let's start off by going with what we have. As I mentioned, there's already a couple of isobars drawn. Let's work around those. But first off, I find it a lot easier starting around the low pressure area. So in this instance, let's draw the 1,000 millibar contour like I explained before, because that's going to be the lowest one of that 4 millibar set that we do. There are a couple of places where it is 1,000 millibars, so it's easy to connect the dots. But then down around this 999 in central Illinois, you kind of have to, again, interpolate, go maybe a fifth the way between 999 and the 1005 down here at St. Louis. So you can kind of get a rough idea of what I did. Next one is we want to draw the 1004. And that one would go like this. Again, I'm kind of eyeballing between the 1,000 and the 1,007. It's a 1004. It's going to be close to the 1005 down in St. Louis. There's a 1004 here in northern Indiana. But then notice on this instance, I actually leave the contours open. I don't continue it all the way around. Oh, looks like I might have actually drawn the 1,000, should have drawn the 1,000 millibar contour up and around this 999 in northern Michigan. But you notice that I leave it open because we don't have any data for Canada at this time, and that's okay. That's fine, but make sure you label it so that you understand. Next one, we're going to go with 1,008. Again, interpolating, connecting where it is 1,008, and just going in between as you go all the way up, leaving it open in southern Canada there. And then we're going to go with the 12. Notice we're going every 4 millibars, 1,000, 1,004, 1,008, 1,012. 1,012 up here in Minnesota, down to Omaha, down to Kansas City, all the way down and around. Notice how close together the contours are. Remember, on a topography map, the closer together the contours are, the steeper the slope is. All right, so now we're going to get a little bit different. We need to do the 1016. We can't bring it up here into the Dakotas. We have to start over here in Nebraska because that's what the data supports. And we're going to go all the way around this low pressure area. Notice that it goes right in between the 1012 and the 1020 that was previously drawn, and we'll go all the way up the east coast. That will pretty much do, because we've already got the other contours drawn. In this situation, we've got the 1020 drawn, but we don't have the data to support drawing a 1024. Remember, our high was 1023. So that's it. You're all done. Now here's what the figure 1A looks like in investigation. Sorry, figure 1 looks like in investigation 1A. Already you've got the 1008 and the 1012. Take a look around. Notice that your lowest pressure is actually up here in Maine, already identified. And then you'll likely have to look down on the western part of the map to find your high pressure spot. But it should be able to get you started pretty well. Remember, start with the 1016 contour and see where you can go. When you get to figure 1B, you'll be asked to do the same thing. Investigation 1B, you'll ask to do the same thing for the whole CONUS with figure 1. And just use the data that's plotted there, finding your high pressure areas, your low pressure areas, and drawing the contours in between. Good luck. Let me know if you have any questions.